Good morning, one and all. Today we are going to discuss about rate law and rate constant. What is a rate law, sir? Rate law is also called rate equation. It is also called rate expression. Rate law and rate constant. What is a rate law, sir? Simply the relationship between a rate of reaction and as well as a concentration of reactant is called rate law. Once again repeat, the, the equation which relates the equation which relates the equation which relates the rate of reaction and concentration of reactant is called rate law. It is also called rate equation. It is also called rate expression. Or one more statement is there. The rate of reaction is directly proportional to the rate of reaction is directly proportional to the product of concentration of reactant with each stoichiometric coefficient with each term with each concentration term with each stoichiometric coefficient raised with some power. That means if you take A reactant and B reactant gives rise to product, the rate of reaction is directly proportional to the concentration of A and B. K is equal to R is equal to K into concentration of A and B. This is rate equation. It is also called rate expression. It is also called rate law. If you take one equation here, Na plus Mb gives rise to product. We don't know product here. But the relationship between rate of reaction R is directly proportional to product of concentration of reactant with each concentration term raised with some power. Here proportionality converted into equal, one constant term is added. Okay, this is called rate equation or rate law or rate expression. For example, if you take here 2A gives rise to product R is equal to K into concentration of A whole square. 3A plus B plus C gives rise to product R is equal to K into concentration of A power 3, concentration of B power 1, C power 1. This expression is called rate equation. A plus 2B plus 3C gives rise to product. What is the rate equation here? R is equal to K into concentration of A power 1, K into concentration of B power whole square, concentration of C power 3. If you take here 1 by 2 A moles of 3 by 2 B moles of B reactant gives rise to product R is equal to K into concentration of A power 1 by 2, concentration B power 3 by 2. N2 plus 3H2 gives rise to 2NH3. What is the rate equation of this equation? R is equal to K into concentration of N2, concentration of H2 whole cube. Only rate of reaction is directly proportional to the product of concentration of reactant, but not in products. I hope it is clear. Like that, various examples are there. If you take NO plus Cl2 gives rise to 2NOCl is there. R is equal to K into concentration of NO whole square, concentration of Cl2. This expression is called rate expression. The rate of reaction is directly proportional to the product of concentration of reactant with each concentration term raised with some power is called rate equation. It is also called rate expression. Okay, I hope it is clear. And the rate equation is always obtained by experimental data. Experimentally, if you take one more example here, now if you take SO2Cl2, sulfuryl chloride, which decomposes to sulfur dioxide and chlorine, the rate of reaction R is equal to K into concentration of SO2Cl2 power 1. Decomposition of hydrogen iodide H2 plus I2, R is equal to K into concentration of HA whole square. SO2 plus O2 gives rise to 2SO3. The rate of reaction is directly proportional to the K into concentration of. These are all various forms of various examples to write the rate of equation. Hydrogen combines with oxygen to form water molecules. R is equal to K into concentration of H2 whole square, concentration of O2. Now what is the rate constant, sir? The rate constant is defined as the R is equal to rate is equal to K into concentration of, for example, NC gives rise to product. Now I am taking equation here, C power N. The rate of reaction is directly proportional to the product of concentration of reactant. For each concentration term raised with some power. K is equal to rate of reaction by concentration of reactant power N. The rate constant is defined as the ratio between rate of reaction and as well as a concentration of reactant is called rate constant. The rate of reaction, the rate constant of a reaction becomes equal to the rate constant of the reaction becomes equal to the rate of reaction when the concentration of all the reactants, that means concentration of reactant, all the concentration of reactant becomes unity or 1, that is equal to rate by concentration 1 power n, then rate constant K is equal to rate of reaction. Like that we should define the rate constant of the reaction becomes equal to the rate of reaction when the concentration of reactant becomes unity. Hence rate constant also is called specific reaction rate. In this case is also called one more name, specific reaction rate. Specific reaction rate. I hope it is clear. Rate constant is defined as the, to take one equation, Na gives rise to product, R is directly proportional to A power N, R is equal to K into concentration of N. This equation is called rate equation. It is also called rate expression. It is also called rate law. What are the units of rate constants? Are K is equal to rate by concentration of A power N. Okay, units of K. Units of rate constant. K is equal to rate of reaction units mole per liter per time. That means mole per liter per second. By concentration of reactant is mole per liter power n. You can observe here mole per liter, A power m by A power n. Okay, that is equal to here mole per liter power 1 minus n per second. Now I am separating these terms. Mole power 1 minus n. 1 by liter means liter inverse, liter power n minus 1 second. What are the units of rate constant? The units of rate constant is mole power 1 minus n, liter power n minus 1 second inverse, where n is equal to order of the reaction. Order of the reaction. Some characteristics of rate constant. What are the characteristics? Characteristics of rate constant. You can observe here the first character is the rate constant is the measure of rate of reaction. The rate constant is useful for the calculate the rate of reaction. The rate constant is the measure of rate of reaction. The rate constant is the measure of rate of reaction. Greater the value of K. Rate constant K is a measure rate of reaction. If the value of K is greater the value of K, rate of reaction also greater. If the value of rate constant is lower, slower, rate of reaction also smaller. That means the rate constant is the measure of the rate of reaction. Is measure of rate of reaction. Greater the value of K, faster is the reaction rate. Similarly, smaller value of rate constant indicates slow reaction. That is the first character of rate constant. And second characteristic is rate constant is depends on nature of reactant. It is also one of the character. Third one is rate constant does not depends on the value of K does not depends on concentration of reactant. That means it is independent of concentration of reactants. The character constant for particular reaction, the rate constant of different reaction is different. That means the value of K is depends on nature of the reaction. It is a characteristic constant for particular reaction at a fixed temperature. Different reactions have different values of K. Different reactions have different rate constants. And fourth one is the value of rate constant for a particular reaction changes with temperature. The rate constant value is depends on temperature. That means as the temperature is K is directly proportional to T, the K value is decreases as the time changes. That means the value of rate constant for a particular reaction changes with the temperature. The units of rate constant is depends upon the last one is the units of rate constant K depends on order of the reaction. And also rate constant is depending upon the catalyst also. These are the characteristics of rate constant. I hope it is clear. Thank you.